Welcome to APCUG's Saturday Safari, where we explore technology in depth. Today we have an exciting presentation. It's another hardware. We do a lot of software, but we've started trying to incorporate hardware. And today we are so fortunate to have Greg Skalka back with us. He's been a presenter with us, but mostly has to be on a Saturday Safari or the old virtual technology conferences because he still works. So he's not free on Wednesdays. Greg's been a member of the Under the Computer Hood user group. I think it's pronounced APCUG, since 1989, when it was first called the San Diego Health Users Group, or SDHUG. He's been a president of the group for 28 years and has written over 300 newsletter columns and given, well, a lot of presentations. He works full-time as an electrical engineer for a defense contractor in San Diego, and we're hoping the weather isn't too bad for him coming up. And he spends his part-time trying to figure out how to retire. We got clues for you. We got experts here. His tech interests include Windows PCs and laptops, Chromebooks, smartphones, cameras, video, GPS locations, and home automation and security. But today, Greg is going to be talking to us about USB testers. And USB testers are small but yet mighty. These relatively inexpensive devices can make measurements while powering or charging USB devices and batteries that can help debug problems and provide insights into battery capacity, charge rates, and the best way to charge. So I'm excited. This is going to be new for me, and I hope it's going to be new for a lot of you. So I'll turn things over to Greg and tell us about this neat device that you showed us.
All right. Thank you, John. And it was the San Diego Heath user group. If there's any people here that remember in the very, very early technology, there were Heathkit things and Heath computers, and that was what this group that I'm part of now started out with. But once they kind of went by the wayside, we had to come up with a new name for our group, and we clung on to the kind of hands-on, under the hood moniker. So that's why we became Under the Computer Hood user group. Well, thank you for having me. I'm going to share my screen here, and you should hopefully see the presentation that I am about to give.
We're good.
And it will be USB testers. What are they and what you can do with them? It's another kind of fun little gadget. I like little electronic gadgets, and this seemed irresistible when I first found out about them. And you can see one here on this opening slide. These devices are relatively small. You can see the scale. Those are USB-A connectors on each end. And so you can see it's not a very big device, but it's got a little display on it. And this one's pretty complex, got lots of different things to show, but I'm hopefully going to give you an idea of what it can do, what all that means, and why you might want to have one. There we go. Oh, now I've messed things up. There we go. My buttons aren't advancing. I've got to do it with the mouse. Never mind. All right. USB testers are an inline type of device, as you could see from that picture that I had on the last screen. You've got two different connectors, a male and a female, or plug and socket, one on each end to connect to. That one is a USB-A type connector, but you would plug it in series with something you're trying to do with USB. If it's charge a phone, you can put it in line with that between your AC, power source and your phone, with the cable going out then to your phone. You plug this into that charger device. You can hook anything that's USB into it. You can test a number of different things. This type of device can ones measure voltage, which for those, I'm an electrical engineer by trade, so I know all these things, but I'll try and make it understandable for everyone. Voltage in electricity can be kind of likened to pressure in a water system. Higher voltage, higher pressure, and the current is more like flow, so higher pressure means higher flow. And power is a combination of those two that measures what you can do. So those are basic measurements that can be made with most any of the USB testers you'll find on the market. Some can also do measurements on other things. The typical factor or unit of measure they use for USB battery packs is milliamp hours, which is kind of a capacity accumulation or charge. It's milliamps of current per hour. For some reason, they use that as the typical capacity because it's always typically assumed 5 volts is what you've got for a USB situation for the voltage. But you can also measure on some of these energy accumulation, watt hours. This is, or typically milliwatt hours. You typically buy your power from your utility you pay for it in kilowatt hours. It's the basic energy unit of measure. And so you can measure that with these. Other measurements that you can sometimes do depending on the device, load impedance, which is a derived measurement from the voltage and current. Temperature, these a lot of times have a temperature sensor in it, in that little dongle that measures temperature. You might think, well, what's the point of that? But it can have some significance, and I'll talk about that later. One really neat capability that one that I have does is it can identify quick charge modes. Now, when some of these cell phone devices standardize different fast charge modes to charge phones, and that's typically where they all came from, was cell phone stuff. They keep developing newer, faster ways to charge the phone, something everyone wants to do, charge your phone faster and faster. Poor people don't want to be running out of battery power and have to, plug in. And that was one of the hints that I saw in the paper for people dealing with the hurricane stuff that we're going to soon have tomorrow in San Diego, is make sure you've got, your phone charged. It's a good idea to have a couple of batteries charged up for that. And then how fast you can charge your phone from them can be important. But manufacturers have developed different charge modes, and they designate them, and you can then, with these testers, it will identify what those are, because those charge modes are a communication between the charged device and the device that's being charged. They have like handshake signals between them, trying to identify what capabilities the load device can have, and if the source device can supply power at a higher rate by using higher voltage or something like that, then it will do that. But it will only do that when both sides are compatible with each other. And so this little device intercepts this and can identify some of those codes. Unfortunately, these things change all the time. As we get new phones, manufacturers create new modes, new technology. They come up with new ones. This device, typically is a snapshot in time. So your USB tester may not be able to identify all the latest quick charge modes, but it can identify some, which is very useful. They typically, as I said, have a male or female plug receptacle connectors, one on each end, so that it, is plugged in between what you typically have as a USB source, a wall charger or a car charger or a battery or whatever that you'd plug your cable into to plug your phone or other device into. You can then plug this tester in and then the cable into the tester, or put it at the other end as well, but it goes in line. A lot of them have USB-A, because if you look at the stuff you've got probably most of it still has USB-A, the large size connector, but USB-C is becoming more prevalent, and so there are USB-C testers. There are some other USB connectors that I do have USB charging needs for, some little bike lights and things like that, that they have some of these older, smaller, but now kind of going by the wayside connection types, such as USB micro or USB mini connectors. I've not seen any testers with those, but obviously you could buy adapters to adapt to them. I've seen one that says it operates bidirectionally. Typically, I think these are meant to go in line from a source to a destination in terms of the power or current, but there was one that said it would also go bidirectionally. It could charge one way and then for some reason pass power the other way. I don't know much about that, but thought I'd mention that. And this is a little picture of sample of some of the different form factors, styles of USB testers that you can find on Amazon. As you can see, there are a number of different ones. This one in the upper left corner, you saw that on the first page of my presentation. It's one I've got, and it's just USB-A to USB-A, very small. It's got a very complex display with multicolors. Some of these have displays that are much more simple, just a monochromatic, limited information. Others have lots of information. Some have USB-A and C built into them. Others are USB-A or USB-C only. I found one that had a cable on it, which might be handy in some applications, but there's a wide variety out there. So if you want to spend, you have idle time, you want to figure out what's best, there's plenty of choices on Amazon. In the research I did in looking for testers that I wanted to buy, I found that they range from as low as $3 to up to $60. And those are non-professional. I say that because there are ones on Amazon that I would class as professional grade USB testers that maybe come in a little case and are certified with, have calibration certifications and things like that. And they can run in the, hundreds of dollars, $300, $400. But most people aren't interested in those. The type that I'm talking about are ones that typical consumers might want to experiment with. The best sellers on Amazon are in the $13 to $25 range. Some specify USB 3 capability, and some don't really specify what they're capable of in terms of USB standards. So I decided I was only going to look at ones that said they were USB 3 compatible. And in looking at these testers, I also found a small class of devices that were of interest. USB loads. I mean, obviously you can use a device that you've got as a USB load, a smartphone or a flash drive or something like that. If you want to see if your USB charger, power source was working correctly, but a USB dedicated load, resistive load might be a better way to do that. And here are a couple that I found. A strictly resistive load. It's just a power resistor and some switches to switch these resistors onto the power pins of the USB connector. This is more complex. Here on the right, it's got a fan to require cooling for it and other adjustments that you can have on it, but it's meant as a USB load. And you can use it in conjunction with one of these testers to do testing of sources or other different things. So of these different USB testers, some are just basically a USB DMM or a digital multimeter. They just provide a voltage, current, resistance, and power measurement. Some, as I said, can store a cumulative charge, which can be handy if you want to determine, oh, gee, I bought this 10,000 milliamp hour battery. Does it really do that? Does it have about that capability? Or, oh, I've got this device that has a battery in it, like my bike light. I've wondered, well, how big a capacity battery did they build into that when they did it? And you could measure those kinds of things with that cumulative capability. I've seen some of these testers that have a Bluetooth interface and a phone app so that you don't have to kind of bend down and look at the thing when you've got it plugged into the wall to see the information. You can have it displayed on your screen, but I didn't think that was that important. So I didn't look at that. What can you do with these things? If you're measuring voltage, you can see, well, G is my voltage out of the USB port that I'm looking at correct? Is it supplying the specified amount of current? Can it supply the right amount of power? You can test different things with these capabilities, such as cable testing. Are you concerned that maybe your cables aren't robust enough to fully pass power to a device? It also, in some cases, have capability. I haven't really experimented with it, but my tester has it, to look at the voltage levels on the data signals. That's the only real thing that, would be reflective of data testing on a USB cable with one of these USB, or anything with one of these USB testers. Mostly, I think they're intended to test power. But you can do battery charging tests. How long does it take? When is a battery charge completed? Sometimes devices have an indicator, indicates, oh, it's fully charged. Others don't. You just leave it on there till you get tired of it. And with one of these devices, you can tell when it stopped drawing current and see. Power source testing, if you've got USB devices you plug into the wall that have USB ports and you want to see, do they meet the specs? Do they provide enough power? You can do that. USB power consumption testing. You want to see how much power your USB flash drive or your USB external hard drive takes, then you can do that. That can be handy. I've got a USB flash drive that I plug into a external USB hub, and it also has a network interface, and it's the network interface for my laptop. But I found when I plug this USB external drive into the USB hub on this device, my laptop's PC indicates it's not connected to the internet anymore briefly. And I believe it's because it draws so much power, it pulls that power down for the Ethernet part of that, and it loses its connection. But as soon as the platter spins up and power drops, then it goes back online. So, investigating something like this, a USB tester would be a useful thing. So what kind of device did I buy? This is the one that, after looking around on Amazon, I decided this would be a good one. It's a MakerHawk USB 3 tester. It was only $13 at the time I bought it, which is, I don't know, 6 months ago. But it's very small, displays a lot of information, including the charge modes, which I thought was of interest. And I use it a tremendous amount. In fact, I've got something plugged into it right now in another room. But I find them very useful. I looked at, after having that one and playing around with it and finally figuring out all the different modes and all the different settings and what the different values were that it displays, I realized, oh, I do have some devices that are USB-C, and there are all these other ones, but you really can't investigate what they do a lot of times without having one. So I thought, oh, I ought to get another one. And after looking at them, though, I decided the one I had was really good, but I and if I needed different interfaces or USB-C or whatever, it's cheaper to just go buy adapter packs on Amazon, and I can use those for other things too. But I did become fascinated with the USB load, and I found that the same device that I had was packaged with one of these resistive loads on Amazon for $2 more. And I'd wished, I should have just bought that one. But I'd had this now for months, and I thought, well, I could use a spare, so I bought it as well. Unfortunately, I've not really played around with the load, but it's good to have a spare because I really use these devices a lot. And this is information from that tester's, brochure or whatever online. So this is kind of outlining its different features and the things it does. It's, like I said, very compact. It's the model AT34 made by some Chinese company, but it seems to work pretty well, and it's pretty, robust. I'm not really concerned about damaging it, but like I said, for, $15, I got myself a spare. And it can test all sorts of devices. If you wanted to test the ports on your laptop, for instance, it in most cases isn't going to be able to test the charging of your laptop, because most laptops are not charged through a USB port, but through some other proprietary type of connector. But any of the USB port outs, you can. So this isn't going to be able to test everything. It's only going to test things that are USB based. You can test mobile devices, such as phones or tablets. You can, test charging of them, monitor their charging, and also look at loads on them from, any other devices you plug into those tablets or smartphones. Power banks are a primary thing that I use them for in checking. Obviously, some power banks, I've bought one type from Costco that is charged directly from a 110 volt wall outlet. It's got a plug that, rotates up, and you plug it into the wall. So I can't test it being charged, but I can test discharging it into other devices. But for power banks that you have that are USB based to charge them, you can verify how they are charged, what their capacity is within certain accuracy. You can also use tester for monitoring the AC chargers that you have to see that they're working correctly or what you would expect out of them, as well as car chargers that convert 12 volts to USB. You can test data cables with it. I've not tried that, but you can use this type of tester to see, are you getting power through it? And like I said, this one, and I'll talk about it a little more later, has the capability of looking at the data signal levels. And then they put in this whole thing, electronic load. So you can use this with an electronic load to verify chargers or power banks under a kind of a generic electronic load. The display on this is very detailed, has lots of information. It's not that big, so having a magnifying glass to go along with it would be very useful. And some of the colors, admittedly, are harder for human eyes to see, especially in a lot of light or without some magnification. But it's got a full display of all sorts of detailed information, and it has 2 mode settings that you can go through. It has only one button to control it, so that you have to kind of read the instructions as to how to change things. But it does do a lot of things. It has the capability of rotating the screen so that you can, if you plug it into the thing in the wall and it's backwards from what you're looking at it, you can have it rotated fairly easily. This one does the quick charge mode recognition. So it will display in one of its display modes the quick charge modes that it has negotiated, that the source you're using, and this is testers in between the source and the load, what those 2 devices have negotiated as a charge mode. So I said it's got a temperature measurement in it. You can see it's got a little temperature thing and the temperature display here. I don't know where in the device the temperature sensor is. They probably put it somewhere in the middle, because I could see if you wanted to monitor temperature, you might either want to monitor the heat generated by a AC to USB, adapter that you have this plugged into, or conversely, a device like a flash drive that you plug into the receptacle on this device, so that you can determine the temperature of it. It's just a relative thing. But I do have one flash drive that gets really hot, I've noticed, when it's running, and you can see that with the device. They say that it's a precision measurement. It's as good as any kind of voltage measurement, current measurement device you're going to find. I don't know that it's good, but unless you get calibration specs from my engineering experience standpoint, it's not. It does read to a number of significant digits. It does have a data storage capacity in that you can put it in a mode where you can have it keep and accumulate the milliamp hour and milliwatt hour readings, that capacity. If you're trying to see how big my power bank is, you could plug it into the charger and it will start, if you have it in this mode, it will start charging up and accumulating. You'll see those numbers increasing as it adds charge and energy to that pack. If you unplugged it, if you're still in this mode, it retains that information, and you plug it in again, it will hold that information and continue it. Or if you unplug it in the non-holding mode, it will at least hold it until you've plugged it in again, and you can write it down if you needed to for keeping records of that. And so with that, it can measure the capacity and energy that you would be putting into a power bank. Now, this device has active circuitry in it and a display. So in addition to just passing the power through it, it's consuming a little bit of it. And that can affect your readings if you're trying to find something out about this and take some measurements that you can draw some conclusions from. But you can't get rid of all the detection circuitry, but that doesn't draw very much current anyway. The display is probably a much bigger element, and so there is a screen off function that you can use to turn the screen off. And it will measure a wide range of voltage, current, and that with it. Here it's talking about, this is just their advertising stuff, their display as compared to other ones, some of these similar to the ones I showed in that sampling that I took from the Amazon screens. And they're claiming their screens are superior and show more information. They do show a lot of information, and that, but there, as I said, I've found the numbers are sometimes a little small, and I'm finding my eyes are degrading, and I need help with that. And especially some colors, red is sometimes difficult. So if I'm charging something, I may turn the light off to be able to see it in the room, or use the magnifying glass. But I can't argue that it does display lots of useful information. Now, here are two of these alternate settings that you can display. And one of them is this voltage on the data lines, and it will show what the positive and negative, because the data in USB is a differential serial data. It will show what those voltages are. I don't really know what that means in a real world sense. If it can't be terribly sophisticated because these things change at high rates. But if you're interested in doing that, you'd have to do more investigation about it. But it is a capability that they advertise. The one, though, that I use all the time to look at is this quick charge mode. And here, this is displaying an Apple 2.1 amp mode. You can go online and get what these different codes mean to see what they are. But they do have this note: this quick charge protocol recognition mode is only for reference. Mobile phone update is fast, and it cannot be identified with 100% accuracy, meaning that this was built at 1 year, and as more manufacturers come up with new quick charge modes, this isn't going to recognize them because it was only programmed for the ones that were in existence then, or the ones they were able to put into it. So as time goes on, maybe there'll be ones it can't. So, but it's a snapshot in time and can be useful. It does have, they say, 4 bits, but it's really 4 significant digits of display, which is pretty good. They say, oh, only 2 to 3 significant digits on some of these other ones, lesser accuracy, but accuracy and precision are 2 different things if you're aware, and this is more marketing than anything else. You can use it to measure discrete loads, but as you're measuring anything, it will display an equivalent load resistance value on the display. It's more for reference if it's just a thing that you're charging like a device. This would only make, have some real significance to you if you're trying to determine, oh, is this USB load resistor really 5 ohms? And it would allow you to do that. Here are the technical parameters of this device. So you can see it will measure voltage from 3.7 to 30 volts. So you may say, wait a minute, I thought USB was only 5 volts. And there's tolerances on that it's supposed to be acceptable. But now with some of these quick charge modes, USB chargers and devices can operate at much higher voltages, so they can transmit power faster and charge more quickly. And you can have voltages on the USB if the source and destination negotiate it correctly and agree that they can do that, and that's part of the USB protocol to be able to do that, then they can put 9 volts or 12 volts or even more onto the USB power pins to charge it. But obviously it has to be negotiated, because you wouldn't want to suddenly throw 12 volts out onto your flash drive when it's really only expecting 5. It can measure current up to 4 amps, and shows all these different ranges that it can only work to 113 degrees Fahrenheit and down to freezing. So, but it's not likely I'm going to want to be in the room with it when it's at 113 degrees. As you can see, it's very small and has a lot of capability. Its display refresh rate is 2 hertz, which is pretty fast. And so this is a close-up showing all of the display information on the normal screen. But you can see it's got a lot of information packed onto it. These are on the main screen, the cumulative functions that I talked about, that you can show milliamp hours and milliwatt hours. And those are really an indication. Milliamp hours really an indication of, they typically list as a charge capacity of a battery. So it's current per unit time, milliamps in an hour, whereas the milliwatt hours is really an energy, and that's, as I said, what you would be billed for from your utility is watts or power per unit time. But you can set it in 2 different ways to hold this and never reset it, so that you can unplug and plug and it will accumulate it, or it will hold it for 1 cycle and then reset not long after you plug it in a second time. And like I said, you've got all these different things displayed on the front panel or the main screen. Voltage, current here in blue. The lavender is the effective resistance. This white is watts or power instantaneous, but then you've also got these cumulative ones in red, the milliamp hours, and in yellow, the milliwatt hours. But then there's a button on the back, which is here. Guess I've got that described later. I can talk about it, but these symbols here on the side show what that button on the back can do to set different factors in this display. I said it's not super complicated once you get used to it. With only one button, you've got to kind of multiplex functions, but it is simple enough to use and still packs a lot of features. So you can set temperature, the data group, and screen rotation off of this extra menu that's activated by this button. And as I said, it also does this temperature measurement, but I don't really know whether it's at this end or that end. They probably made it in the middle so that you can read either source or destination rough temperature, and you can set the mode to be either Celsius or Fahrenheit. The thing comes in a nice little plastic box, which is really cool. And as I said, I bought this load resistor external load, which I haven't really used, which could be useful for testing devices. These are the different displays that you've got. As I said, I described all of these. When you're in the second mode, when you press the button, you get the display of the voltages takes this place of the milliamp hour, milliwatt hour, and the quick charge mode goes here. Now, these are some applications that I have of what I've tried to do with it. I have this flash drive that I wanted to look at, and so I plugged this SanDisk flash drive in, and you can see it only draws 5 volts, about 0.129 amps. And as you can see, it makes this a little hot. It's 104 degrees, 105 Fahrenheit, and it's using the DCP 1.5 amp charge mode, which is dedicated charge port 1.5 amp. This is part of the battery charging specification of the USB standard. So when you've got this plugged in and recognized in Windows, it's drawing about 0.129 amps, 128, 129 milliamps when it's running. When you eject it from Windows, even though it's still plugged in, it then goes to 0. Here is this flash drive and the USB hub and network device that I've got. I wanted to see how much this thing actually draws. So I plugged the tester into this USB port, which goes to a USB-C port on my laptop, and then plugged the cable for the external hard drive into the tester. And when I just plug it in, but it's not being used, it's just spun up and sitting there, it's drawing 250 milliamps out of the USB port. I tried playing a video, and you could see, the current increased to 337 milliamps. As you can see, it is a little hotter, but it's not getting that heat transmitted from the cable. It's reading it out of this port, apparently. And so then when you are running, as I said, it's running at 250 milliamps. But then when you eject it from Windows, it's still running. The platter apparently does not stop, but some of the electronics is shut off, and so then it drops to 116 milliamps roughly. So you can, if you're so inclined, have lots of fun playing with these kinds of devices and your other USB things to see what they draw and what they do. And as I said, I determined for using with different types of USB connectors, be it USB-C or mini or micro, the best thing that I found is, I just have this one USB tester with USB-A type connectors on it, and I buy USB adapters off of Amazon to adapt it to different things, rather than buying one of these ones that has 4 connectors or a separate one for USB-C. You can also use this to measure the current USB-C hub with Ethernet. So this is a demonstration of using it with adapters. I plug a USB-C adapter to USB-A into my laptop, plug the tester into it, and have another USB-A to C adapter to run this hub. And I found this hub takes 194 milliamps to run. And why you might want to use the rotation of the display, if you plug this charger into a wall outlet and the display is normally upside down, you can press the button and go to the mode that will change it to be the other way so you can see it. And so here it's reversed the right way. These are a little, what's called a Wise Light, W-Y-Z-E. It's a company. You can buy these on Amazon. They're really nice. They have a battery in them, and you can put them up on the stairs so that when you want to go down the stairs, it will turn a little light, and they're just a stick-up light, so they're rechargeable. You don't have to wire anything into your home, but they do have to be charged every couple of weeks, and this shows charging them. And it's an Apple 2.1 amp mode that it uses. Here's a power bank, and this is one of the applications where you can get higher voltage on USB. This is charging a 20,000 milliamp hour power bank, and these power banks take a long time to charge. They don't charge at high voltages. They don't charge at high current, so it takes a long time to charge it. But then if you use it with a cell phone that has a good charging mode, like my Samsung S22, then you can use this tester to see it charging in a fast mode. And you can see that, oh, it charges using the QC 2.0, Qualcomm Quick Charge 2.0 mode the phone is capable of, and apparently that charger is, and it's charging at 9 volts on USB. And a considerable amount of current, 1.6 amps going into that phone. So the battery in that phone gets charged pretty fast. You can also use these to determine if charging is complete. As I said, I've seen devices, I have one right now that it doesn't tell you when it's done charging, but you can put one of these in line to see when the current drops down, then you know that charging is done, as opposed to just leaving it on there for days and then assuming it's done. And these things came with nice fancy storage containers. So I've kind of run quickly through the last part of this, but want to make sure there's time for questions. That's my presentation. Hope you enjoyed it. If you have any questions, I guess I'll stop sharing now. And if there's any I can provide answers to immediately, I can.
Hey, great. Thank you so much for the great presentation. It was quite interesting, and I've learned a bunch of stuff that I was clueless about and that I guess I should know. Anyway, I have a question. Is MAH and WH the same?
MAH and WH, no. The H is the same in both of them. That stands for hours, unit of time. But MA before that is milliamps, which is a measure of current. It's 1,000th of an amp. And so that is current, or in other words, if you're kind of thinking in the analog of plumbing, it's the flow of electricity. Whereas WH is watts, which is power, which is voltage times current, which is more volume. If you thought of a plumbing system, just for those that aren't that familiar with electricity, current would be the flow through a pipe into a container, whereas wattage is power, is the accumulated amount of water you'd have in the container after it was pouring into there. So they are different.
Does fast charging an iPhone at greater than 5 amps shorten the overall battery life?
Well, these devices are supposed to, provide, in other words, the phone will provide to a charger the different protocols that it can use safely, that the Apple designed the iPhone for, iPhone to do, and the charging device that you're using, plugging into the wall, is supposed to be able to identify those, and those two devices will communicate and identify the charging modes that are capable of both devices of supporting, and then we'll use the common one that it can that will give you the fastest charge. So if you're using a phone and a device in that mode, it shouldn't shorten the life if it's going to be running at a higher than 5-volt rate. The manufacturer is intended for that, to give you that capability. There may be a way to disable that in the phone. I don't know if you're paranoid, but it should work. That should be perfectly safe.
Thank you. For us non-electronics people, what does load mean?
Well, the load is whatever is consuming power. If you've got a battery pack and you plug your phone into it to charge it, your phone is a load. It's drawing current power off of that battery pack. But things like a phone or a USB drive are variable. They're semiconductor devices in them, and it will vary over time. To do tests of a USB source, it's often good to have a fixed load, which doesn't change in the amount of current it will draw at a given voltage, which would be a resistor. And so that's why those are used, and you can use that as a load. But anything that's drawing current out of something is a load. In your house, if you plug a light bulb into the wall socket, it's a load on your electrical system.
Okay. Hold on. Have you tested very low currents, 10 MA, against a known test circuit? I find my tester with only plus and minus 10 MA resolution won't report 20 MA device loads at all.
That is one thing that I haven't done a lot of, is testing how good this device is at low resolution, what its real test limits are, and how accurate it really is. As I said, I bought 2 of these, and I said one time, well, I'm going to try both of them and see how they compare. And they actually compared very closely with the same, charging the same device. So at least they manufacture them consistently, and the design is such that they're consistent. But yes, what it reads, as I said, these devices do draw some power off of the circuit that's providing power to them, and that, I don't know if that gets factored into the displayed value or not. And so that may play into whether or not at low current you measure things accurately or not. I've not done much research on that.
Mm-hmm. Can they be used on a Raspberry Pi?
If the Raspberry Pi has a USB connector on it of some kind, C or A or whatever, then you can, on either the supply to the Raspberry Pi or any USB ports that you would hook some external peripheral to from the Raspberry Pi. Any USB connector on any kind of device, you could use one of these USB testers to test.
If you plug a powered USB hub with 10 plus hard drives attached into the tester, what can you determine?
It probably pulls a lot of power.
That would be my answer. Or they all blew up.
Well, if you're the only thing you can tell, like I said, this is an inline tester, so you can make up some big load of something, and you're going to have to put it into something with this in between to get any readings. You can plug this into a source like your wall socket with nothing hooked up to it, and it will read, is it putting out 5 volts at the right, tolerance? You'll see that there's no current, no power, but it doesn't start doing anything until you plug this in. If you had some big, massive setup of drives, if you plug it into this without putting it into a source, you wouldn't tell anything. But if you're concerned about, is it something going to happen to it, you could find that out without the tester, plug it into a source. I'm not sure that answered their question or not, but that's my interpretation of what they're asking for. I don't know.
That is the last chat box. Oops, wait a minute. Hold on. Can any of these devices be used at the load end of a charging cable to check the voltage drop through the cable?
Yes, you can do that. If you plug the cable into your USB power pack or USB wall charger, and then plug the tester into the cable and then the device directly into the tester, you would be able to, see what the voltage is at the device itself as close as you can. You could do a comparison test if you're concerned that there's a lot of voltage drop in the cable, hook the device up and have the charger at the wall plug end first and see what the readings are, and then move it to the other one. Unfortunately, if you're doing it with a device that has some variable current, it's a flash drive or something like that, it's harder to tell. That's one application where using the fixed load resistor device would be perfect, because it wouldn't change from time to time. It should be exactly the same. It's not going to vary with voltage or current. It's going to present the same resistance. So you could get a much better view of what the voltage drop between, the front and the input and the output of the cable would be, is if you're using one of those USB load resistors. But yes, you could use that to put it at either end.
When I charge my phone overnight, I use a low 1A power charger. I understand a low power charger heats the battery less, which increases its life. Can you talk about this fact? Is it true or false?
If you are using a charger that has limited current capability, it will charge it at a lower rate. But as I said, unless you're feel there's a conspiracy and the manufacturers are designing things that they want to fail earlier, if you're using one that has higher current capacity and it negotiates a charge rate that is higher, then you'll get it to charge faster. Whether it's damaging to the battery, it's difficult to tell. I suppose in the grand scheme of things, all things being equal, because you are heating the battery in general more, it would be true that it might last longer, but it should be safe enough if the manufacturer of the phone thinks that it's safe to do.
Is there any way to record data versus time?
Data versus time. Well, I do that, and I have a notepad and I just write it down. If I'm charging something and I want to see what it's, what the charge rate over time is for a battery pack, I will go and, write down the time, that I started and what its, voltage and current readings are, and come back in an hour and see what it is now, write it down, see what the capacity it says on the battery is, and you could do that. There isn't an inherent way to do that with a device this simplistic.
Do not throw out your paper and pencil.
That's true, yes.
Have you revealed any problems with computer hardware by using the tester?
So far, no. I haven't had any problems I've tried to diagnose. It's mostly been kind of playing around, seeing what I can learn about them. Like I said, it does solve a problem of a couple devices I have that don't give an indication of when they're done charging. But it also has helped me figure out the best way to charge my Samsung S22 phone, because even though it will say with the phone charger that I have that came from Samsung, you know, it's in a quick charge mode. I have this battery pack that it will put in a quick charge mode that it will actually charge it a little faster. And you can see the higher current rate on this tester. You wouldn't see that any other way. You might have to wait and see, well, gee, I timed how long it took to charge, and it's a little harder to do. But with this, you can see, you know, real hard data that the current is higher with this device charging the phone than some other device.
Cool. Thank you. And this is my really last question. Greg, where can we go to get a cheat sheet that tells us what the numbers are good, like when you get a blood lab?
A cheat sheet?
You know, this is what this means.
I suppose the best, if you have questions about it, I don't know of a cheat sheet, but you could Google it. Maybe there's a cheat sheet out there that you might be able to find, you know, using USB testers. There might be something out there that you could use. I will
Google that just for grins. Hey, thank you very much for a great presentation. And now we're going to go to live Q&A, and John is going to close the chat box. Kurt Trout, you're on. John, can Kurt unmute himself? There.
I can. I want to thank Greg for a great presentation. I've had one of these for a long time. Okay. I bought it specifically for use with Raspberry Pis. So yes, you can use it for Raspberry Pi. And one of the things that I found that has me sort of puzzled, okay, I like to, especially for the older Raspberry Pis, power them with old cell phone chargers, the little 1 amp and 2 amp chargers that used to come with phones. And I have been powering Pis with that and had them report low voltage. And that's why I have one of these, okay, and they will do that. And unfortunately, what I found is they may take and report low voltage even when I can see that the input voltage is right at or very, very close to 5 volts. So I've never figured out why we have that discrepancy, since I presume that the Raspberry Pi is measuring input voltage. But they are handy for that. You've given me a good idea for a device that I have. It gives me no indication when it's charged. And I'm going to start doing that. So thank you very much.
You're welcome.
Jerry Crow.
Good morning. At least it's morning here. Some people may not be aware that one of the most important factors in battery life for a lithium battery is to keep it, don't charge it to a full 100%. In fact, the standard recommendation now is never go beyond 85% charge. Now, how do you do that? Well, simple. For example, in an Android phone, there's a setting. I've got mine set that way. Somebody said they had an S22. That's what I've got. There's a setting in there that you can say, stop charging at 85%. And then I also found out that it's an older Dell, but I went into the BIOS setup in the power management, and I can do it there too, stop it at 85%. So if you have an iPhone or an Android, you might check to see if you can turn on the option. I don't know about the iPhone, but I say again, the option does exist in later versions of Android to tell the phone to stop charging at 85%. So that's reputed to increase the life of the lithium-ion batteries.
Cool. Hey, thank you. If somebody has an iPhone and they can do that, let us know, because he was speaking about an Android. David Cunningham, you're on. Please unmute yourself. David Cunningham, do you have a question or a comment? Joel Sandberg, it's your
Good
turn.
afternoon. Thank you for your presentation. I've had a device similar to this for several years. I'd like to recommend to all of our users, one of the best applications for this type of a device is to monitor the charging of your data packs, your battery packs. I end up with a drawer full of batteries from who knows what manufacturer and another drawer full of chargers. So I'm very often not matching the manufacturer of the battery with the manufacturer of the charger. So the automatic charge shutoffs may not be working properly. If you use a device such as what was explained today, you can watch the current dynamically as it's charging. And when the current flow slows down, that's when you've reached charge. And the battery is telling you that it doesn't need any more. So I recommend using something for this to learn how long it takes each charger to charge each brand and size of batteries. And you will find that a larger 10,000 milliampere hour battery does draw more current than the smaller 3,000. So a device like this is very good for monitoring the dynamic charge, and you see what's going on, and you see when the charge current goes close to zero, and then you're done. Thank you.
Thank you. And I have two more questions. What is a safe range for USB ports, particularly those that provide power to other devices?
Safe range. Typically, the original USB spec was just 5 volts, and there's some spec for it, but now they've expanded it to being able to, if it's negotiated in these, quick charge modes, I know it can go over, 12 volts. I don't know how high it has, but if you're looking at a USB port on a, device, a laptop or something like that, and you don't have any load, you put one of these testers into it and it's over 5 volts, there's something wrong with this port.
Can any of these devices be used at the load end of a charging cable to check the voltage drop through the cable?
Yes, I explained that.
Okay, thank you. And that is all for me for sure, because it's Miner's turn.
Good morning. Neat idea. I just see if I can bring this up so you can see it. That's a little tester. It's called the MC 25, I think it was, that I've had for several years. I was just trying it on a battery pack, and it showed me that, well, the reason the battery pack's not going to charge is because it's shorted. It kills the tester. So the interesting thing to troubleshoot stuff with, and good presentation, and enjoyed it.
Thank you.
Steve Parker.
Yeah, I've got an iPhone, and what I did was to program a automated shortcut in it so that when it gets to 80%, it vibrates and it sends alarms off and has a little hissy fit that it's at 80% and to turn off the charging. And when it gets low, when it gets to 20%, it says that it needs to be attached to the charge. So you can Google or on YouTube, there are plenty of tutorials on there, videos that show you how to program the iPhone to do that. I haven't found one that'll shut it off at 80 or 20, but I'll take a look and see if I can find one.
Thank you so much. Appreciate that. And that is the end of my questions. And I have to say, I see no more raised hands. So again, Mr. Skalka, thank you very much for the very educational presentation. Clear, concise, terms people can understand, hopefully, and you make sure everything is charged up in San Diego. I'm going to do the same thing in Santa Clarita. You jogged me, Judy. Make sure that your phone is completely charged before Sunday.
And even besides charging your phone, I've got 2 of these 20,000 milliamp hour packs, which are incidentally are the largest that TSA lets you take on a plane in terms of capacity, sitting here. And they normally run my phone in normal use for about a week each. So, you know, if you have a couple of those, then you're in good shape, even if power doesn't come on for a while.
I will locate those. I just hope if it goes off, it comes back quickly and I don't lose everything in my refrigerator again and freezer.
That's the real problem is,
Which
yeah,
is
there's
what
no way to
happened.
protect that other than start eating.
That happened a couple of years ago when our Electric SCE shut everything down, preventive maintenance when a fire was coming our way. Steve, did you find an answer to your own question?
No, there was something else I wanted to say.
Oh, okay, sorry.
By keeping the phone within the 20% and never letting it go above 80, I've had the iPhone for like 3 or 4 years now, and the battery rate that it gives is still at 98%.
Okay, so
with an Android phone, I kept it on and I had it charge up to 100%, and the rest of it, if I take it off the charger, it's dead within an hour. So it does make a huge difference. Keeping it between the 20 and 80 doesn't use up a recharge cycle on the phone's battery.
okay, so what you're telling me is when I plug in my iPhone and it sits there for well over 24 hours or more, it's okay to do that.
It's degrading the battery.
Thank you.
Don't let it go above 80. And
Got
don't
it.
let it go below 20.
Oh dear.
And you
Poor
can set up notifications that'll tell you when it's got to 20 or it's got to 80.
Thank you for that. How cool, David Cunningham. Unmute. There you go.
Okay, can you hear me?
Yes, we
Yes.
can this time.
Great. It's amazing how much better things work if you plug in your camera microphone. I wanted to thank Greg for his presentation and ask a question that is more centered on USB data than USB power, which was most of his presentation. I bought a group of unpowered USB hubs and was testing through them and destroyed a flash drive. It simply stopped working after that and wouldn't work in any other device. And somehow, I think probably cleaning up in the middle of a project, I mixed the bad hub back in with the group. And I'm wondering if he knows any smart way with a tester to see if, for instance, there's a short feeding 5 volts down a data line or something, which could have fried my flash drive.
You could use one of these testers with no load on it as a load to, if you got like 5 hubs sitting there, you don't know which one has a problem. I would plug the hubs each individually, separately into a source, and then plug the tester into one of the hub, maybe, each one of those sequentially, and first check to see that you've only got 5 volts coming out of the hub. If one has more, then you've found the problem. If you suspect that there might be excessive voltage on the data line, as I showed in the brief slide that showed the one screen on the one I've got that will show what the 2 differential voltages on the data are, if you flip to that screen while plugged into each hub port, you could see those, and they should be, 2.4. None of them should be over 5 volts or should be at 5 volts. And so you could go through each of your hubs on each of the ports with no other thing on it but the tester to see if you can detect something like that, and that could possibly identify your bad hub.
Yeah, that might be a way to do it, simply running that test repeatedly on different hubs. And when I find something that is markedly higher or lower than the normal, then I have got at least a suspect of which one is the bad one.
so I don't have to go frying a bunch of flash drives. Great, thank you, Greg.
Okay. Jerry, Edward, Stephanie, and Roy. John is going to open the chat box. If you will please put your questions and your comments in there. Greg needs to move on for the rest of his day, and we need to learn about technology and genealogy. So my last thank you, Greg. I appreciate it.
You're welcome.
I was bugging you about this, and along came the Saturday Safari.
Saturday works okay.
Yeah.
During the week, sadly, I'm working.